This video is to help you with the Geometry Unit 2 test. You can either send me a message with your answers to these questions and I can adjust your grade for you, or you can retake the test after watching this video and see if you are happy with your grade on your retake. So the first thing I want to go over are the different properties. And then there's two questions I'm going to have you answer. So this is a picture from a document I have posted in the Google Classroom in Unit 2. So the first one I want to talk about is the commutative property. So commutative, I think of commuting, moving, commuting. I'm going to go over two examples here. If I have 2 plus 3, I can switch the order. I can move those numbers around and add 3 plus 2 and I would get the same answer. The same for multiplying. 5 plus 4 is the same as 4 plus 5. You can always change the order that you're adding or subtracting numbers and it'll be the same. Associative property is about associates, about grouping, like I'm associating with you and now I'm associating with you. So here I can have 5 and 1 grouped together and then add 3. Or I can have 1 and 3 grouped together and add 5 to that. So when you are adding or multiplying numbers, it doesn't matter which numbers are kind of within the parentheses together, which numbers are associating together. You can move those parentheses around when you're adding and multiplying, and you're going to get the same answer on each side of the equal sign. The identity property is just saying if you have a number and you add 0, it's always going to be that number. Or if you have a number and you multiply by 1, it's always just going to be that number. It's going to keep its identity. If you add 0 or multiply by 1, it keeps its identity. It doesn't change. Where inverse is like opposite. So if you add the opposite number, the answer will always be 0. Or if you multiply by the inverse, then it's always going to be 1. So that is the inverse property. Couple more. The property of 0 is just saying that if you multiply by 0, the answer is always going to be 0. And then the distributive property you're probably familiar with. That's just saying if you take the number outside of the parentheses, you can multiply by each number inside of the parentheses because of the distributive property. So you use these properties when we're doing proofs to justify making changes. Oh, there's a couple more. The reflexive property is saying that a number always equals itself. So sometimes in a proof you just need to say 3 equals 3, or the measurement of line AB equals the measurement of line AB. That's the reflexive. I think of that as reflection. Same thing on each side. Symmetric is somewhat similar to that. Let's take a closer look here. So, except it's the same thing, but you just switch sides. X equals 3 is the same as 3 equals x. Or 5x equals 30 is the same as 30 equals 5x. And then the transitive property is the longest one of them all. It's saying, like, if I say this equals 7 and I say this equals 7, then these two must be equal to each other. So that is the transitive property. So if you need to rewind and look at those again, these are the two questions, question 18 and 13. You need to identify the property. The ones that are marked in gray, this is not the answer. This is the one a student picked and it was incorrect. So it's not these. So picking from those 4, what is the property that's being illustrated? Now I want to go over a proof, and the proof in the on the quiz is that our test is actually very similar to this. This proof I have a video of posted in the Google Classroom. So here with a proof, you're always given some information. So here we're given that AB, so the distance between A and B, plus the distance between B and C equals the distance between A and C. So always kind of look at your picture and see, what are they saying here? The orange piece plus the red piece equals the purple piece. Then they're telling us what A, B, or AC is. They're saying A to C is equal to 2x plus 1. So from A to C, that's 2x plus 1. Then it's telling us from B to C is 3x minus 2, or 3 minus 2x. And from A to B is 6x minus 4. So they're giving us that information there. That is our given. Now they want us to go through the different steps to prove that x must equal 1. So for this one, I actually wrote down the steps, and we're just going to practice identifying the reasons. So the first step is always to list what is given. So I can say this because it was given to us. It's the information they told us is true at the beginning. Now let's look at what the first step to kind of go through the process of proving that x equals 1. So what I did is I took AB plus BC equals AC, and I substituted in what AB is, and what BC is, and what AC is. I took these and I substituted them all into that equation. And so the reason I can say this now is the substitution property. The substitution property allows me to substitute whatever AB and BC and AC are into that equation. Now I'm going to simplify this. So I'm going to go through and I'm going to combine my like terms. And then on the right side, I couldn't combine anything. So the reason I was able to change it from what I wrote in 2 to what I wrote in 3 is you just write simplify. I just simplify. I just combined my like terms. Now let's see, what did I do from step 3 to step 4? Now to solve this equation, I need to move all the variables over to one side. You see that 2x isn't on the right side anymore. I must have subtracted 2x, and then I subtracted 2x here. And that's how I got to what I'm now stating in step 4. So what allows me to subtract the same number on both sides of the equal sign? That's called the subtraction property of equality. You can subtract the same number on both sides of the equation because of the substitution property. Now what am I doing? What did I do next? Okay, I moved that minus 1 to the other side. I added 1 to both sides. So why could I change it to 2x equals 2? Well, the addition property of equality allows me to add the same number on each side of the equal sign. And then my last step, now I'm down to just x. What did I do? I divided by 2. So why can I write this? I can write that because I can divide both sides by 2. That's the division property of equality. So with these proofs, what you're doing is you're changing the statement, going through the different steps, and then the reason you're saying is, I can change it to this because of the subtraction property. I subtracted the same number from both sides. That's why I could change it to this. So on this next page is a proof from your quiz. Very similar. They're even giving you some choices up here where you're picking from A, B, C, D, E, F, G, H. So it's very similar again. Read through, then ask yourself, what did they do? It was this, and now they changed it to this. What allowed them to change it to this? And then it says simplify. Okay, let's simplify this, and what do we get? And then the subtraction property of equality allowed you to do this. And then what did I do to each side to get to this? So that is what you're doing for this question here. And then the last thing I want to go over are conditional statements, and we're just going to do 2 questions on this. So a conditional statement always starts off with a hypothesis. So you start off with a hypothesis and you end with a conclusion. So if we look at this first statement, it says, if I eat a pint of ice cream, that's my hypothesis, then I will gain weight. Then I will gain weight. So if I eat a pint of ice cream is my hypothesis, that's my condition. If this happens, then I will gain weight. The other thing I want to go over is the converse of a conditional statement. This is the opposite. So you start off with your conclusion. If I gain weight, then I must have eaten a pint of ice cream. So the pint of ice cream is what leads me to gain weight. Gaining weight is not what leads me to eat the pint of ice cream. So eating the pint of ice cream is the condition, and gaining weight is the conclusion. So that is a converse of a conditional statement. So these are the 2 questions. Again, the one chosen is not correct, so we know it's not this one. Which of these is an inverse of a conditional statement? Actually, I don't think I went over inverse. Let's look at that again. An inverse is saying, if I do not eat a pint of ice cream, then I will not gain weight. So that's the inverse. It's the opposite of your hypothesis and the opposite of your conclusion. You can take, if I eat ice cream, then I will gain weight, and just add the nots in there. And now it is an inverse. So this is the question I would like you to do. Question 12, and again, this is not an answer. Which of these is the inverse? And then this one, again, this is not the answer. A conditional statement, the part that expresses the conditions is called what? So again, please either message me the answers to these questions I have in this video, or retake this test and hopefully you do better.